into algebra. And we talked about negative numbers before just to help us work with some of the topics in algebra or some of the things we're going to be doing in algebra. And we've talked about variables. Variables are just unknown numbers. They're numbers. So we could do to variables the same things we do to other numbers. It's just a mystery number. We got to try to figure out what the mystery number is. So what we're going to do, we're going to talk about how you sort of deal with these variables. So when we talk about like terms, we talked about types of terms. So this would be like a type X. And so if you're going to say what's a like term for something that's type X, and you had these to choose from, well, this is a type X. And when you determine type, it's the variable and any exponents, and the exponents have to be on the correct variables. So this is a type X squared, and this is a type XY, and this one is a type X. So that means this and this, they're the same type. So that's how we identify like terms. And again, we're looking for the variable and any exponents that are on the variable. What we don't pay attention to is the number that's attached to the front of the variable, or what we call the coefficient. That we can ignore because this is a 3 and that's a negative 71, doesn't matter. But because there's no exponent here, but there is an exponent here, that matters. So let's take a look at gathering like terms. Now, I gave a rule last time, but we're going to dig a little deeper. We're going to dig a little deeper. And let's see where this rule actually comes from. So let's take a look at 3x. Now, in algebra, and this is just the language of algebra, it's one of those things you just have to memorize. But when you have a coefficient in front of a variable, it really means multiplication. This is 3 times x. And multiplication, well, that's just repeated addition. So this is x plus x plus x. The same way, if you have 3 times 5, it's 5 plus 5 plus 5. So that's a key thing with like terms. So this is how we come up with the rule. We'll use an example to show how this comes about. But let's say we have 3x plus 2x. Well, let's go to the rule of addition with multiplication. Or I should say, let's express this clearly as multiplication. But then what we'll do, 3 times x is x plus x plus x. And 2 times x is x plus x. Now, how many x's do we have here? Well, there's 1, 2, 3, 4, 5 x's. So because we're adding the same thing repeatedly, we can rewrite this as a multiplication. 5 times x, or using the language of algebra, because algebra likes those little shortcuts, just 5x. So this is going to lead to a rule. And the thing with algebra is we're looking for shortcuts. We're very keen on those. So here's the shortcut. This is our rule. If we take 3x plus 2x, we know the answer is 5x. So what we can do, we can give x a coefficient of 3 plus 2. We just add the numbers in front. And that gives us 5x. So what's happening here is we're using a shortcut to summarize a whole bunch of stuff going on in the background. Questions about that? So let's do another example. And if I'm going too fast, let me know. So let's say you have something like this. Now, each of these terms is type xy squared. So you have 4 xy squareds. We have another 17 xy squareds. And I guess we're going to let our friend borrow 5 xy squareds. So we're going to lose some here. But each of these terms is of the same type. So we can combine like terms using that rule where we just combine the coefficients. And so that's going to be 16x y squared. So questions about that? Now you notice that I've made this big stink that the terms have to be of the same type. And there's a reason for that. Why do we not combine unlike terms? I mean, what's the harm? They've got some x's, some y's. Why do we worry about the details on this? Well, let me show you. We don't combine unlike terms. And the reason is this. They can represent different numbers. And the problem is when we combine unlike terms, we're making one of these different numbers disappear. That means we've changed things when we shouldn't have. So let me go through an example of that with algebraic expressions. Let's say Again, if I'm going a little fast, let me know. XY squared plus x squared y. Now these are two different types. This is a type xy squared, and this is a type x squared y. So let's say we do this. Let x equal 3 and y equal 5. Well, what does this become? Well, xy squared plus x squared y will now become 3 times 5 squared plus 3 squared times 5. Or 3 times 25 plus 9 times 5, or 75 plus 45, or this becomes 120. So here, let me move this over to the side so you can see the whole problem. Add those two together, you get 120. So that's what happens if we let, oh, I'm sorry, I forgot to put the x in here. This is an x. So let x be 3. Don't forget to put that x in there. I apologize. Y be 5. And so we take this expression, we're going to get 120. So what happens if we try to combine these terms? Let's say we're going to do something we're not supposed to do. So we're going to do an oops. We let xy squared plus x squared y, and we say, you know, they're all kind of very similar. Let's just say we have 2 x squared y. Why not? Let's combine them. I mean, the 2, it just needs to be on the y. Isn't that close enough? Well, it's not. These are totally different terms. We can't combine them. And so if we try to combine them, and then we make our substitutions, we replace x with 3 and y with 5, we're not going to get the same answer as before. We'll get 2 times 9 times 5, and it doesn't come out to 120. It comes out to 90, which is not the right answer. And the reason is xy squared is a different kind of number than x squared y. When we combine them, we basically erased this number and replaced it with something else. We replaced it with another xy squared, and that's not going to work. That's like pretending this doesn't exist. So that's why we don't combine unlike terms. So let's do some more combining. So any questions about that? Now, you might get some pretty, how does one put it? Well, let's say we have this. We won't make it too complicated just yet. And usually what you're asked to do is simplify. So what we're going to do, we have a type X, type X, type Y, type Y. So we can group the terms of the same type together. And then if we add these, we'll get 10x plus 16y. And because these are different types, that's as far as we can go. We can only simplify so much. And so that's going to be our answer. Questions about that? All right. So let's say we have something like this. And we're not limited to x and y's. Now, I mentioned last time, we typically choose x because it's easy to write and it doesn't look like other numbers. But you're going to find they're going to use all kinds of variables. And you got to be careful that if you write this wrong, it could look like a 9. You got to be really careful of that. But if we don't make that kind of error, if at least if we're clear, maybe that we don't have to worry about that as much. And so we can use variables like this could stand for the number of pizzas. This could stand for quarts of ice cream. You can use variables that are more meaningful. Now, once again, we're going to gather like terms. So we have some type P's. And we have a type PQ. Now, there's nothing for the type PQ to combine with. But there is something for the type P's. They can combine. If you add 1.5 and 3.1, you'll get 4.6p plus 0.30 p times q. And that's going to be your answer. Now, questions about that? So that's the idea of combining like terms. Now, what we're going to look at next we're going to look at distribution. And let's say we have something like this. Now, what this means, when you see a number next to parentheses, in algebra, that means multiplication. So what this says is we have 3 times this quantity x plus 2 in parentheses. Now, what this means is we're going to add x plus 2 to itself 3 times. Now, there's something, and let me take a look here. I know in the other algebra classes they mention this, and it doesn't seem to be something we talk about here. Let me just double check, because this is kind of an important thing for this trick to work. Yeah, they don't mention it. But for addition, and multiplication, order and grouping don't matter. Give me a second there to write that down. For addition and multiplication, order and grouping don't matter. To show what I mean, and I don't mean to sidetrack too much, but if you take 2 plus 3, that's the same as 3 plus 2. Regardless of the order, you're always going to get 5. And then for grouping, let's say we want to put parentheses around the 2 plus 3 here. We add these two first to get 5. We get 5 plus 1 will give us 6. But if we move the parentheses over here and we do the 1 plus 2 first instead, and then add the 3, you know, we're going to get the same answer of 6 both ways. This also works with multiplication. It doesn't work with subtraction or division. It does not work with subtraction or division. 2 minus 3 is not the same as 3 minus 2. Anyway, a little bit of a side discussion. So what does this mean? Well, what this says here is these parentheses, because it doesn't matter if we do x plus 2 and then instead of doing 2 plus 2 plus 2 or x plus x plus x, we're going to get the same answer. So what this implies, since the order and the grouping doesn't matter for addition, we can just add the x's together and then add the 2's. And again, only works if you're doing addition or if you're doing multiplication. A little trick that's going to help us out here. Now, how many x's? We have 3 x's. So that's 3 times x. How many 2's? Well, 1, 2, 3. So that's 3 times 2. So we go back to the beginning. Pardon me for just a moment. We start with this, which is multiplication, which is repeated addition. And then because order and grouping don't matter with addition, we can get rid of the parentheses and move things around. We get this and this, which is this and this. I bet that's kind of a lot of work. But ultimately, this is what we discovered. 3 times x plus 2 is 3 times x plus 3 times 2. So what does this mean? Well, can we come up with a shortcut? And we can. And that shortcut is what we call distribution. Now, this is definitely a shortcut. There's a lot of stuff that are going on behind the scenes, and we've done all the behind the scenes stuff. Again, if I'm going a little fast, let me know. So here's our shortcut. So you have 3 times x plus 2. So what we're going to do is distribute the 3 to each of the terms in the parentheses. And we distribute it as multiplication. And so we'll just cut to the chase and say 3 times x plus 3 times 2. And then we can simplify this. This will become 3x plus 6. Questions about that? All right, so let me do an example. Now, something like this, if you want, you can combine like terms in the parentheses first. So this will be 2x plus 4x minus 6y. And so we'll have 5 times 6x minus 6y. Now, these don't combine. As tempting as it is to say this is 0, we can't. This is a type x and a type y. They're actually two different numbers. But now we distribute. And so we'll get 5 times 6x minus 5 times 6y. And that gives us 30x minus 30y. So what's sort of the benefit of distribution? One of the benefits of it, distribution allows us to drop parentheses. That's a big deal because with parentheses, we're told we have to do what's in the parentheses first. But here's the thing with variables. Until we know what number x represents and what number y represents, we can't come up with a number to be in the parentheses. We're stuck. So the way we get around that is we distribute the 5. When we distribute, we can drop the parentheses. And there we go. We've got our answers. So questions about that? So taking a look at parentheses, let me double check. I want to make sure I say this right. If there, and this is on the topic of dropping parentheses, is only a plus sign in front of parentheses, you can drop them. And you can drop the parentheses, not the plus sign stays. But you can drop the parentheses if there's only a plus sign. So let me give you an example of what that looks like. So let's say you have this. Well, in this case, there's only a plus sign in front of the parentheses. So that means we can drop them. We keep the plus sign, but we drop the parentheses. And so we're going to group these. This is type M squared. So we have 8 m's. We're adding 2 more. That gives us 10 m plus 4 m squareds. And that's it. That's as far as we can go. Questions about that? And when we talk about a plus sign being in front, it's that plus sign. That's the one we're talking about. We're not talking about what's on inside the parentheses, but what's in front. Now, there's another sort of special rule of distribution, and it's if you have a minus in front of parentheses. This minus is distributed. So, for example, let's say we have this. Now here, we've got a minus in front of the parentheses. So this gets distributed to here and to here. So what happens when we distribute this? Well, this becomes, it's a positive 5y. So you put a negative onto a positive, it becomes a negative 5y. This is sort of like the opposite operator that turns positive in the negative and negative in the positive. Now, when it gets to this, there's a minus already in front. So negative and negative, think multiplication. They multiply to become positive. So that becomes a positive number. And then we can gather the like terms. In this case, this is type constant, type y. So that's going to be negative 3 minus 5y. And that's going to be your answer. Questions about that? So just to make a note, when you're distributing a minus sign, it's the same. You get the same effect as distributing a minus 1. Get the same effect. So let me do one more example here. Do kind of a complicated one. And again, if I'm going a little fast, let me know. So let's say we have this one. Well, now we've got two things to distribute. We're going to distribute the 4. And it gets multiplied to each term inside this set of parentheses, but only this set. And then we're going to distribute the -6. So the 6 will take the minus sign with it. So when we do that, what we're going to get, we'll get 4 times x squared minus 4 times 6x plus 4 times 8. Now, -6 times x squared minus 6 times x squared plus -6 times 3x minus -6 times 5. So this becomes 4x squared minus 24x plus 48 minus 6x squared. This will be plus minus 18x minus -30. Now we're going to do some cleanup here. Adding a negative is the same as subtraction. Now, technically, I should leave it as adding a negative, but we don't have to. So I'm going to make it a subtraction. But there's some algebraic rules that would prefer that this stayed adding a -18. And it has to do with the ability to group and change the order of addition, which is something you can't do with subtraction. The way you get around that is you take subtraction, convert it to adding a negative. But I'm not going to sweat the detail on this one this time. Negative is a positive. And so now we combine like terms. So we have 4x squared minus 6x squared minus 24x minus 18x plus 48 plus 30. So 4 minus 6, -2 for x squared. -24, subtract an additional 18, -42x. And then for the constant, type constant, that's going to be plus 78. And that's going to be our answer. Questions about that? All right. So now we're going to start talking about solving for x. So that's the idea of simplifying, distributing, gathering like terms. So now we're going to look at solving. And we're going to be looking at equations. Now, if you've noticed, you haven't seen many equal signs. So what's going to happen with equations is that this is where one side equals another. That's the idea of equations. Or another way of thinking out of it, both sides are balanced. Both sides are balanced. So the way to think of this, it doesn't matter what the two sides look like for them to be balanced. So we could have like a 3-pound weight, a 1-pound weight on one side, and then two 2-pound weights on the other. But as far as balancing goes, it's going to be 4 pounds. And so that's the idea of equations. Things have to be balanced. That's what this equal sign means. Now, we can use this as a way of solving for unknowns. And the way we can do this is this. So any questions about that? So let's say we have this. We have an unknown, and then we have some weights. Now let's say these are balanced, they're equal. So how do we know how much X weighs? Well, X weighs 2 plus 3, and let's say we're using pounds, or 5 pounds, because it's balanced by 5 pounds. So the way we write this mathematically is we say X is balanced by 5. Now let's take a look at another one. So any questions about that? All right. Now let's take a look at another one. We're going to have this balanced. So we have some unknown weight. Here's a 2-pound weight. Here's a 2-pound weight. There's a 5-pound weight. So how do we figure out what X is? Well, you can eyeball this. You can say, well, that's 2 and that's 2, and this is 5, and these are balanced. Well, this also has to be 5 if they're balanced. And you'd be absolutely correct. Now, what we do in algebra is we could remove 2 pounds from each side. So if we take 2 pounds away here and 2 pounds away here, what we'll get is x and then 5. And so this says x equals 5. So that's how we can find a solution. We remove 2 pounds from each side. Now, that's using weights. Let's talk about this in terms of algebra. Well, the way we express this in algebra, on one side we have x plus 2, and on the other side we have 5 plus 2. And then we subtract 2 from both sides. And so that leaves us with x balanced by 5. Questions about that? All right. So let me show you another one like this, and then I'll kind of give you the sort of the lowdown on how this is all working. Let's say you have this. So these are going to be balanced. So you have 3 x's, and let's say it's balanced by 3 3-pound weights. Now, again, you would probably say, well, clearly this is, well, we don't know clearly. We know these have to be the same thing. X represents the same number. So that must mean each of these x's must each be 3s. And you'd be right. For these to balance, that would be correct. Now, what we do in algebra is we go about it slightly differently. We'll divide both sides by, because there's 3 numbers, we have 3 x's, we'll divide by 3. And so when we do that, we'll have x, only one of these, only one of the 3's. And so what this tells us is x is balanced by one of those weights. Take the number of x's, divide by 3, so you only have 1 x. Take the number of 3's, divide by 3, so you only have 1 3. So you have an x balanced by a 3. If it was 4 x's, we divide by 4. So how does this look in algebra? Well, in algebra, this is 3 times x equals 3 times 3. So there's 3 x's, 3 3's. We divide by 3. You can kind of think of this as how we cancel numbers using when we reduce fractions. When we reduce fractions, we cancel numbers by dividing. So this will cancel, this will cancel. And so we get x is equal to 3. Questions about that? So let me give you the full story here. So the way we solve for variables we solve by canceling. And the way we cancel is we use opposites. So what kind of opposites are we talking about? Well, addition and subtraction are opposites. So if you add 3, let's say you don't have any money, and someone adds 3 to you at $3, you now have $3. But if you want to send you back to $0, you subtract 3. So the opposite of adding 3 would be subtracting 3, and that keeps you at 0. And then multiplication and division are also opposites. So if you have $5 and I triple that, that's 3 times 5. You go from $5 to 15. So if I multiply 5 by 3, I get 15. But if I take 15 and divide by 3, well, that brings me back to 5. So multiplication and division, they're going to be opposites of each other. So we're going to use this to solve for variables. So let me give you an example. So let's say we want to solve for x. We want to get x by itself, just like we wanted to get it by itself on the scale. So that means we want to cancel the +3 or that +3. So the way we do that is we use the opposite. Instead of adding 3, we subtract 3. Now here's the thing though. What we do to one side, we have to do to the other, just like with the scales. If I remove 2 pounds on this side, I have to remove 2 pounds on this side to keep things balanced. So that's a key thing. What we do on one side, we must do on the other. That's key. We have to keep things balanced. So a +3 and a -3 will cancel. And this becomes x. And then 7 minus 3, or 7 subtract 3, that's 4. So the answer is x equals 4. Questions about that? All right. So let's do another one. We have y minus 7 equals 10. So we want to cancel a minus 7 or subtraction of 7. So the opposite is adding 7. So the opposite of subtracting is adding. Take y minus 7 is equal to 10. We add, and what we do to one side, we have to do to the other. These will cancel. And then 10 plus 7, that's 17. Questions about that? All right. Let's take a look at another one. So let's say you got 4x equals 12. Now remember, there's a number in front of a variable. That's the same as 4 times x equals 12. And again, we're going to look at opposites. Now, in this case, the opposite of multiplying by 4, that's going to be dividing by 4. So to cancel this, we're going to use that. So again, addition, subtraction are opposites, and then multiplication and division are opposites. So we divide both sides by 4. Now these two will cancel. And then 12 divided by 4 is 3. So you get x is equal to 3. Questions about that? All right. And here's another. We'll just do a bunch of these. And there's some ones you can get with fractions that get a little complicated. Now, let's say we have this. X over 2 equals 6. Well, in algebra, fractions, and this is true in general, this is the same as x divided by 2 equals 6. So again, we want to look at opposites. The opposite of dividing by 2 is multiplying by 2. Multiply both sides by 2, we're going to be okay. So we do 2 times. Times 2. Again, with multiplication, order doesn't matter. You can do 6 times 2 or 2 times 6, either way. You could do 2 times 6 if you wanted to. But with multiplication and addition, the order doesn't matter. Subtraction, division, it does, but not for these. So these will cancel, the multiplication and division. So that's just going to leave us with x, and then x is equal to 12. So there's a little trick with fractions I want to show you real quick. Well, we'll get to that a little later. Let me do one other thing. We want to talk about PEMDAS. In fact, let me put it vertically. Recall PEMDAS. So when we think about PEMDAS, we do what's in parentheses first, then we compute exponents or square roots, then we do multiplications and divisions, and we treat them like they're on the same level. When we compute them, just whichever shows up first from left to right. And once we've gotten rid of multiplications and divisions, we then deal with additions and subtractions, and we treat them on the same level. We go left to right. Well, for algebra, or for arithmetic, this is what we do. Oh, shoot, you can't see that. Let me write that again so you can see it. Got a little overzealous with my PEMDAS. So when you're doing arithmetic, parentheses, exponents, multiplication, division from left to right, addition, subtraction from left to right. So this is what we do for arithmetic. For algebra, we go in the opposite direction. And we cancel as we go. So we go through PEMDAS backwards. So that means for algebra, instead of doing parentheses first, which you actually can, you can do it too, you can distribute to get rid of parentheses, that's okay. But for algebra, this is what we're going to do. I'll abbreviate algebra here. We cancel addition and subtraction first. And then we cancel multiplication and division. And then we're not going to really deal with exponents, but then we'll cancel as necessary. I'll put this in parentheses. We're not going to deal with worrying about, well, no, we would do this. We didn't cancel exponents. And then what's inside the parentheses, if there's anything left, we'll cancel those. So in algebra, we go through PEMDAS backwards. So here's PEMDAS. So here, let me put it like this. You can see it backwards. But we go through PEMDAS, but in the other direction. We go like this. And instead of performing the subtraction and addition, we cancel them. Instead of performing the division or multiplication, we're going to cancel them. Instead of computing the exponent, we're going to cancel it. And then once we get inside the parentheses, we'll cancel what's ever inside the parentheses. So let me give you an example of what this looks like. So any questions about that? You can think of this as undoing a process. So for example, let's say we have 5x plus 3 equals 48. So if we think about the computational process, what usually comes first, if we follow PEMDAS, if we knew what x was, we would do this first, and then we would add 3 second. That's our process. For algebra, we're going to reverse all this. We're going to undo it. We'll cancel adding 3 first, and then cancel multiplication by 5 second. So with algebra, we work backwards and we cancel things. So let's see what this looks like. So according to PEMDAS, if we knew what x was, we would multiply first, then add 3. But since we're doing algebra, we're going to go backwards and cancel. We're going to cancel the addition of 3. And that's going to give us 5x equals, and then 48 minus 3 is 45. And then we cancel the division by 5. We're going to get x equals 9. Now, one thing you can do with algebra, if you're not sure if you got the right answer, especially if you're checking even problems, you can check your solution. And so the way you can do this, our equation says 5 times x plus 3 equals 48. So let's replace x with that number 9. Is 5 times 9 plus 3, is that equal to 48? Or is 45 plus 3 equal to 48? Well, it certainly is. So that tells us we've got the right answer. Now let's take a look at another one. Any questions about that? So let's take a look at another. So let's say you have something like this. So here's a pro tip. When you have something multiplied outside parentheses, you can do this one of two ways. You can either distribute the 5 to get rid of the parentheses. We'll do it both ways. Or we can divide by 5. We'll go through both methods. And again, this is the power of distributing. We can distribute to get rid of parentheses. Yeah. And so what that's going to give us is 5x minus 15 equals 30. So now we're going to reverse things. Following PEMDAS, we usually multiply first, then subtract. Algebra, we're going to do the opposite. We'll cancel the subtraction first. We do that by adding. Adding and subtraction are opposites. So that's going to leave us with 5x equals 45. The opposite of multiplication is division. So we divide both sides by 5. We'll get x is equal to 9. Got 9 again. So that's one way of doing this problem. I'm going to show you the second way, show you how to check the answer, and then that's going to be it for this evening. So the other way of doing this, again, if I'm going too fast, let me know. So the second method we recognize this is 5 times x minus 3 in parentheses. So we're going to follow, if we follow PEMDAS, we would evaluate this first because it's in parentheses, and then we would multiply. But if we do the opposite of PEMDAS, we're going to undo the multiplication and then cancel anything inside the parentheses that we need to cancel. So the opposite of multiplication is division. We'll divide by 5. And again, what we do to one side, we have to do to the other. And that gives us x minus 3. 30 divided by 5 is 6. Now, if we take a look at this, what's in front of the parenthesis? Well, there's an invisible plus sign. There's no minus and no number to distribute. So we have an invisible plus in front of parentheses. So what that means is we can drop them. So we get x minus 3 is equal to 6. And so now I just got to cancel what needs to be canceled that was inside the parentheses. To get x by itself, we need to get rid of the subtraction of 3. The opposite of subtraction is addition. So what we do to one side, we do to the other. And so we get x, again, is equal to 9. And we should always get the same answer. So any questions about that? So lastly, I'm going to check the solution. Both methods, we get the same answer, and that's what we would expect. So to check the answer, I'm going to give you some terminology. Replacing a variable with a number is called substitution. So what we're going to do to check our solution, we're going to replace x with 9. We're going to substitute x with 9. So we have our x. We're going to replace it with 9, or substitute x with 9. And we're curious, is this in fact true? Do these sides balance? We're going to get 5 times 6. Does that equal 30? And sure enough, it does. We get 30 equals 30. So our solution is correct. So that's it for tonight. If you have any questions, let me know. What I'm probably going to do with the exam, let me see. Let me see. Let me check the schedule. What I'm thinking of doing with the exam is doing a take-home exam just for time. I'm going to need the class time to finish up on algebra Thursday, so we can do trig next week, and then that's it.